All right, I'm going to talk through these guys. This computer just shut down on me after I'd obviously done a little bit of work. So if it's all right with you, I'll do less writing and more explaining about what's written. All right. So we're going to use end behaviors, more specifically what happens when A is positive or A is negative, x-intercepts and y-intercepts to graph a polynomial function. So here we go. The very first thing you're going to do is you're going to find out whether your A is positive or negative. And that's the number right in front. I guess the sign right in front is what it is. And I see that's a positive 1. If you want to check back, anytime the A is positive, as x goes right, y goes up. So I know that as at the far end of my graph, it goes up. And that's usually the first thing I graph. I come over here past all my x-intercepts, and I know it goes up and up, or right and up in this case. And then I'm going to go ahead and put my x-intercepts. That one right there, if I set that equal to 0, has an x-intercept there. If I set that equal to 0, that's negative 2. If I set that equal to 3, it's negative, or 0, it's positive 3 x-intercept. And I start over here because I know my graph went up. I know because that's a first degree, it goes through. I know that's a first degree here, it goes through. And that's a first degree here, and it goes through. And I get that graph. All right. I'm going to come over and do this guy. And then, you know what, I'll probably erase this guy and do it again so you can kind of see the progression as we go along. First thing I do is I find my A is negative. So since A is going to be negative, that means as my graph goes right, it goes down. So as it goes right, my graph goes down. And then I find out, and I wouldn't draw my graph yet, I'm going to find out my intercepts at 4, at 1, at negative 1, and at negative 2. And once you get that, you can kind of graph it. You know, as x goes to infinity, y goes to negative infinity, and all these are first degrees. So I go through at 4, I go back through at 1, I go through at negative 1, I go back through at negative 2. And I get my graph already. And the only thing you really have to do is write your x-intercepts, negative 2, negative 1, 1, and 4, and then figure out your y-intercept. Your y-intercept is found by knowing that your x value is 0. So if I plug in 0 all of these places, right, I get 0 minus 4, 0 minus 1, and I'm going to point to where I'm at, 0 plus 1, and 0 plus 2. And then I just solve that out to get an output of negative 4. So that would be my y-intercept. When x is 0, y is negative 8. I said negative 4, negative 8. And that's all the information you need. I'm going to go ahead and I'm going to show you how I would do this. I'm going to erase everything here. And we're going to show you the last two. I was going to have you do one, but I'll just show you both. And then we'll practice in class. First thing I know is my A is negative. That means as I go to the right, my graph goes down. All right. I got an x-intercept. If I set that equal to 0, at 0. So I'd put a dot at 0. And I'd also have, if I set that equal to 0, an x-intercept at 4. You see I have them listed 0 and 4. Since I know my graph goes right and down, it touches at 4, and that's a first degree. Okay, it's a first power. So it goes through 4. And then it touches at 0, and since that's a second degree, it bounces off. Boing, and I'm graphed. I see my x-intercepts at 0 and 4. I could also write that as 0, 0, and 4, 0. If I wanted to, that would work. And my y-intercept is also at 0. Anytime your x-intercept's at 0, 0, your y-intercept is all going to be at 0, 0. All right, let's do one more. Come in here. So, first thing I'm going to do is I'm going to point out that A equals a positive number. That means as my graph goes right, as x approaches infinity, my graph goes up, y approaches infinity. So out here I'm going to draw something right and up. And then let us locate. I've got a root at 2. If I set that equal to 0, and I'll show you, x minus 2 equals 0, my answer would be 2. My root is at 2. I've got a root at negative 1, and I've got a root at negative 4. So the graph is done. I know it goes up, right? I know it goes this way. At 2 it goes through because that's a first degree. Let's put my degrees, first degree, first degree. So at 2 it goes through. I'm going to go straight through the graph. At negative 1 it goes through. I'm going to go straight through the graph. And then at negative 4, it it's going to bounce. So my graph is going to look like that. And again, we don't know what the valleys or peaks or the maximums or minimums are going to look like. And then I just need to find my minimum, which I don't really, I'm sorry, not my minimum, my y-intercept. So I was going to find my y-intercept. I would know that the value of my x at the y-intercept is 0, and I would just plug everything in. So here I go, f of 0, right, equals, and I plug in a 0 there. 0 minus 2 to the first power. 0 plus 1 to the first power. And 0 plus 4 to the first power. Well, this would be negative 2 times 1 times, oh, that's to the second power. Look, I missed the multiplicity there, so that's to the second power. Times 16, so it's actually going to be negative 32. So my y-intercept is going to be 0, negative 32. Obviously, I should have gone a lot deeper. That would be my y-intercept right there. I am going to go ahead and stop right there. It's a short video. You know, it's only 6 minutes. I'm going to show you how to do these really quick. And then we'll be done with this portion of the graph, and we can talk about boxes next week. So here we go. We're going to do the same thing we just did, except now we're going to go from graph to equation. It's going to tell you that your a is either 1 or negative 1, so we don't have to worry about that. And let's go ahead and we're going to come here and we're going to figure out our a here. All right. My a is, well, it's going to be a positive 1 because when it goes to the right, so we're going to say a is 1. And here we go. I'm going to write my equation. So I'm going to say y, or f of x, if I want to say that, equals 1. And then every root gets its own parenthesis. So this right here is x plus 3 because it crosses at negative 3. This right here is x plus 1 because it crosses at negative 1. That right there is just x, which I should probably write in front, but I'm going to go sequential. Or I could say x minus 0 or x plus 0, right? And this one right here is going to be x minus 2. None of these roots have any weird behaviors. They always go through. So I don't have to change this at all. It's just going to be straight through. And I'm really pretty much done. This is to the first power, first power, first power, first power, which gives me a 4th degree equation because I just count my exponents across. All right, we got one more. And here we go. All right, so my degree we'll figure out soon. Let's find out what a is. In this equation, a is negative because as I go to the right, so we're going to say it's a negative 1. And I'm going to start writing my equation already. So y equals negative 1, and I've got a root at 3. So I'm going to say x minus 3. I've got a root at negative 2, so I'm going to say x plus 2. Except this one bounces, so I'm going to say squared. So if I count my exponents, 1 and 2, I have a 3rd degree equation. And really, that's most of your notes. We have a box problem to go through, but it's not due till next week. So I'm going to get this posted for everyone that wants to work ahead.